Okay, so we're going to look today at, because I think some people are still a little confused as to how to calculate kind of some simple probability examples, specifically theoretical probability. So let's look at kind of the simpler, and I'll put that in quotes because it's not necessarily always simple, but just kind of a counting idea here. So this is all going to be theoretical probability. So in this case, we didn't no actual experiment done. Okay, so we're not using an experimental procedure or experimental process to determine the probability. So first of all, some reminder of notation, and if you didn't watch the video, you may have missed this notation, so make sure you're watching the videos because that can help. So P of any event means the probability of the event occurring. Now, you won't always be asked to do probability with that P, but that's kind of shorthand for the situation. So, for our first example, if we have a bag of marbles, and it has 5 red, 10 blue, 3 yellow, and 7 green marbles. Whoops. 7 green. Okay. All right. So, first of all, if I want to find the P of red, and the probability of anything, really, is going to be the number of chances of red and over the, okay, and this is when we draw one marble over the number of total chances. Okay, so in this case, the number of total chances would be 5 plus 10 plus 3 plus 7. Okay? So 15 and another 10. Okay, so the total chances are 25, and the number of chances of red are up here at the total of 5, so 5 out of 25. Okay, or you could write that as 1 in 5 if you wanted to reduce it, and this one's easy to change to percent, although you don't always have to. It would be 20% or 0.2 as a decimal. Okay, so some other probabilities you could do. You can do P of an event that is, what's the probability of not choosing green? Okay, so in this case, same thing. Remember, we had 25 total marbles, and there are 7 green. So if we subtract that 7 out of the total of 25, that would tell us how many were not green. Okay, so 25 minus 7 would be 18 out of 25. Okay, now if you want to change that to a percent, you could. And plug that at 430, so that's 72%. And if you want to know how I'm doing that, you don't really need to worry about doing that, but if you did want to change it, I'm setting up a proportion, and we'll use that later to do some other things, but I'm setting this up as over 100, and I'm multiplying that by 4. So that gave me kind of the percent. Okay, we'll kind of do that later with estimates, and also if you want to change these to percents or decimals. Although right now you don't need to worry about it. You can leave things in fraction form. All right, so you can also do kind of combined probabilities. So the chance of blue or yellow occurring on one draw. Okay, so again, blue, there's 10. And yellow, there's 3 here. So my total was still 25. Okay? And I have 10 blue and 3 yellow, so I'm just going to add those up. So it would be 13 out of 25. Okay. And again, if you wanted to, you could multiply that by 4 in 52%. But again, you don't need to. And these should be not too hard to understand how you're going to do it out of total chances. Now, let's say I have a die. One number cube. You'll see it mentioned that it's a 6-sided number cube or just one die. Most people don't use the word die. They say one dice, but dice is technically plural. So don't worry too much about that, but you're rolling a die, one 6-sided number cube. So like the P of like rolling one of the numbers, a 5, let's say, well, it's a 6-sided die, so you have the options of 1, 2, 3, 4, 5, or 6, and you can only roll 5 one way. So that's 1 in 6 chance. Okay, a little bit harder to do percentage, so let's not worry about that right now. You would do 1 divided by 6 to get an approximate percent. And, you know, I'm not really concerned about that. It's around 16.7. So, but if I was going to say P of rolling an odd, for example, I still have 6 options. But if I look at my options for odd, well, 1 is odd, 3 is odd, and 5 is odd. So I have 3 out of 6 chances, which is 1 and 2. A little bit easier to do 50% or 25. Okay. So thinking about like kind of like that, you can also say P of not 3, for example. And the options of not 3 are we could do 1, or we could do 2, or we could do 4, 5, or 6. So it's 5 out of 6. And one way to think of that is like this is a total of 6 out of 6 minus the probability of rolling that 3, which is 5 out of 6. We'll kind of talk about that later when it might be easier to find the probability of doing something and then subtracting all the rest off. In this case, it's easy either way, or it's simpler either way. You can kind of do it either way. All right. Last example is going to be the spinner. Okay, and here you can kind of see that we have 3 kind of darker gray spots, 2 lighter gray spots, and 3 white spots. Now you're going to assume they're all equally likely because otherwise the probability is a little bit harder to figure out. But if they're all equally likely, I have a total of how many shapes or how many pieces. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 pieces. Okay, so everything I do is going to be out of 8. So for example, probability of landing on gray, let's say light gray. So it would be this one and this one. And therefore it's 2 out of the 8 or 1 chance in 4. 25% or 0.25. Okay. But I might say something like P of not white. And we can kind of do this way. There's 3 white. Okay, so if I think of it as the total was 8 out of 8, and I'm subtracting my 3 out of 8, okay, that gives me 5 chances in 8. Or you can just think of it this way, is whatever wasn't white. So here I'm going to put an X on everything that wasn't white. There were 5 of them. That's why that kind of works that way. Okay, so there's some examples. I want you to kind of complete some of the simple practice on the PDF, and that way hopefully you can kind of get a general idea how the simple probabilities work so that when we move into more difficult things, it won't be too tricky. Have a good day.